Hello friends, and welcome to this video related to conditional control structures in Python. Conditional control structures in which conditions are evaluated before deciding what the program does next. In this video, our focus is on these control structures, namely the conditional control structure. They are used in domains ranging from hardware assembly language programming to financial formula in Excel and other spreadsheet programs. By the end of this video, you will have a solid practical and theoretical understanding, and we will be able to use it to direct your program control flow into the appropriate code block based on appropriate preconditions that need to be satisfied. So to understand Python conditions, just look at the problem on the screen. What will this return? We may think we know all about comparisons, but there are some subtle points worth exploring. We will start off by looking at how we can check conditions within our program. These conditions can be used in several ways, most commonly in if-else statements and loops. Programming is all about making decisions based on the conditions that are evaluating. What are conditions? Conditions are statements that returns true or false. Is 10 equals to 10? We all know the answer to this. This will return true. Notice the use of double equal to symbol. This is extremely important. In Python, a single equal to operator is used for assignment, and the double equal to symbol is used for equality. What we want to do here is we want to check if the value on the left is equal to the value on the right. Yes, 10 equals to 10, so this condition evaluates to true. Let's evaluate another condition is 10 equals to 20. And as you would expect, this evaluates to false. Is the integer 20 equal to the string hello? Well, that's false too. This single equal to symbol is wrong here because you cannot assign to the left hand side. You cannot assign the string hello to the value 20 because it's not a variable. The error you get is fairly clear about it. It's a syntax error. You are using wrong syntax. You can swap the left hand side and the right hand side when you are performing equality. This is the same equality check that we had performed earlier. You can perform equality checks with the strings as well. In this string hello equal to the string hello. Well, that's true. But remember, string in Python are case sensitive. Using the double equal to symbol is extremely important when you are performing equality checks with the variables. Here a equals to b basically checks whether the value stored in the variable a is equal to the value stored in the variable b. This is a conditional equality check. A teeny little change here, the use of single equal to, completely changes the nature of the statement. This is then assignment operation. A equals to b will make the Python interpreter take the value of b and store it in the variable a. This is completely different from the equality check that we intended to do. So make sure that you are very careful. Now that you have understood equality checks, Python also has inequality checks. If the value of two operands are not equal, then the condition becomes true. Notice the inequality operator in the Python. It is an exclamation mark followed by an equal to symbol. The statement 20 exclamation equals to 20 evaluates to false. Is 20 not equals to 10? This evaluates to true. 20 is not equal. True, the string hello evaluates to true. The string hello not equal to the string hello evaluates to false because they are equal. Let's see how we can use variable in condition check. We assign the string hello to the variable x. Now when you do an equality check of a string hello with the variable x, it will evaluate to true because it is the value x hold. What will happen if we do an equality check of x with the string Python? This evaluates to false as the variable x holds the string hello, not Python. Let's perform an inequality check with the variable x and the string Python. This evaluates to true. Let's take a look at another comparison operator in Python, the less than operator. It evaluates to true when the value of the left hand side is less than that on the right. Is 10 less than 20? Well, all know the answer to that, so it evaluates to true. Is 10 less than 9? That is false. Is 10 less than 10? That's false too. Let's take a look at greater than operator. The greater than operator checks if the value on the left hand side is greater than that on the right. Is 15 greater than 20? This evaluates to false. In addition to the greater than operator and the less than operator, Python also supports less than equal to and greater than equal to operators. 20 less than equal to 15 evaluates to false. Now what will be the result of 20 less than equals to 20? This evaluates to true. Let's check the condition 20 less than 20 without the equal operator. This evaluates to false. The condition above is only true because of the presence of the equal to operator in addition to the less than operator. Here we want to evaluate whether 2 plus 3 less than 6 or not. But how does the Python interpreter knows that we want to perform the addition operation first and then less than operator after that? There is a rule of precedence in Python. It guides the way in which the operations are carried out. The addition operator has a higher precedence than the less than operator, which is why 2 plus 3 is evaluated first and then less than operator. You can go to the link below and find the table summarizes the operator precedence in Python. This expression evaluates to true. Now we have 2 plus 3 within parentheses. Since the addition operator has higher precedence than less than operator, this statement is similar to the statement above, where the operands of addition, hence this expression evaluates to true. Is 8 plus 5 greater than 10 plus 2? Yes, indeed. 13 is more than 12. Due to the higher precedence of the addition operation, the addition is calculated first on the either side of the greater than operator, and then they are compared. Is 8 plus 5 equals to 10 plus 3? Yes, indeed it is. It evaluates to true. All the comparison operators have the same precedence. This automatically makes the precedence of the addition operator higher than all the comparison operators. The precedence order of the multiplication operator is higher than that of the addition operator, the subtraction operator, and all the comparison operators. Therefore, this expression will evaluate to false. 2 into 5 greater than equal to 10 evaluates to true. Let's check if 40 modulo 3 gives out the remainder 0, where the 40 is perfectly divisible by 3. Would have expected. This condition evaluates to false. Let's check if 40 is perfectly divisible by 2 or not. This evaluates to true. Let's swap the left hand side and the right hand side operands. This condition is exactly the same as the condition above. Therefore, it evaluates to true. So far we have seen the relational operation in Python. Now let's move to and as a logical operator that evaluates to true if both the operands on the either side of the and evaluates to true. The statement that you see on the screen 5 greater than 3 and 4 less than 6 will evaluate to true as both the expressions on the either side of the and are true. The condition that we just evaluated is equivalent to enclosing comparison within a parenthesis. The AND operator evaluates to true only if conditions on both sides of the AND are satisfied. 5 greater than 3 is true, but 4 less than 2 is false. Therefore, this expression evaluates to false. Take a look at this expression 10 equals to 10 equals to true. you would expect this expression to evaluate to true, but this evaluates to false. Let us see why. Evaluation of conditions are from the left to the right. So the first evaluation will be is 10 equals to 10. This is true. But is 10 equals to true? That is false. Is as good as saying 10 equals to 10 and 10 equals to true. Then we evaluate 10 equals to 10 within parentheses and then compare it to true. The Boolean true, this expression evaluates to true. This is because 10 equals to 10 will produce true within parentheses. Then true equal to the Boolean true is true. Let's take a look at another type of logical operator, the logical OR. The OR evaluates to true if the condition on the either side of the OR is true. The expression that you see on screen will return true. This is because 5 greater than 3 evaluates to true. Even if one condition on the either side of the operator returns true, the OR condition will evaluate to true. Let's take a look at another example. Let's take expression 5 greater than 3 or 4 less than 6 here. Both the conditions are true. So this expression will return true. 5 greater than 6 or 4 less than 2. Here both the conditions are false. Therefore this expression evaluates to false. Let's take a look at the third type of the logical operator, the logical NOT. When we use the NOT operator, it reverses the result. It returns true if the expression evaluates to false and vice versa. 5 greater than 3 and 4 less than 2 should evaluate to false. Notice the use of the NOT keyword. Now this expression will return true. Let's take a look at some more example like 5 greater than 3 or 4 less than 6. This expression should evaluate to true, but we are using the NOT keyword, so this will result into false. So in this video, we studied comparison operator and logical operators. Comparison operators are used to compare two values, and logical operators are used to allow a program to make a decision based on multiple conditions. So in this video, we will keep our learning up to here only. And in next video, we'll try to explore more about if statement with primitive data types. Till then, goodbye. See you in next video.